Insects have developed physiological adaptations to survive the predictable seasonal weather extremes that occur annually due to the angle of the Earth's axis. Insects use environmental cues to determine whether it is most advantageous to continue development or to become dormant. What are environmental cues? The two most important are photoperiod, which is day length from dawn to sunset, and temperature. Photoperiod and temperature are seasonal properties and affect the availabilities of other ancillary cues such as moisture, food, and mates. The status of these cues determine if the individual insect should be actively mating and reproducing or preparing to survive harsh seasonal conditions. Being active benefits the individual with mate finding and ample food. However, failing to initiate diapause could result in death if the environment turns hostile. Therefore, it is critical that insects can determine whether to continue metamorphosis and reproduction or become dormant and adapted to survive a deadly climate. Biological organisms reside in a cyclical world. The 365-day transit of the Earth around the Sun is a predictable circannual cycle. In addition, there is also a 24-hour day-night circadian cycle based on the rotation of the Earth on its axis. Because of the axial tilt of the Earth, the day length changes daily by a predictable amount throughout the circannual cycle. It is this changing length of the photoperiod that programs the insect regarding the season and the likely onset of harsh or fair weather. Using the Northern Hemisphere as the example, we shall compare the influence of day length on changing seasons and diapause onset. The lengths of the daily photoperiod and scotoperiod comprise the 24-hour circadian cycle. The circadian cycles are mirror images in the northern and southern latitudes. At the spring equinox, the lengths of the day and night are identical. Photoperiods lengthen in the summer of the northern hemisphere and shorten in the winter, while the reverse occurs for the southern hemisphere during the same circannual periods. As we go from summer to winter in the northern hemisphere, seasonal days change from 14-hour long days with 10-hour short nights at the peak summer solstice to equal 12-hour light, 12-hour dark at the equinoxes to short 10 hours of days and 14 hours night at the winter solstice. In insects with a facultative diapause, it is the duration of the photoperiod during the 24-hour circadian cycle that cues individuals to prepare for the upcoming unfavorable season by the onset of diapause. Winter-induced diapause onset occurs in response to the shortening days of the approaching autumn equinox, and development restarts with the lengthening days of the spring equinox. The next scene will discuss the hormones that are involved in diapause and the physiological processes that have been modified to ensure survival of diapausing individuals.